The third Windows option is WSL, the Windows subsystem for Linux, and it gives you a genuine Ubuntu running inside Windows. Not an emulator, and not a compatibility layer pretending to be Linux. A real Linux kernel. That matters for one specific reason. Every program in this book works unmodified under WSL, including the POSIX-only programs in Part 5 that need real threads and real file descriptors, the ones I have to give you Windows fallbacks for. If you already know you want to work the way most C programmers work, this is a very good choice, and it costs you neither a dual boot nor a virtual machine to look after. Installing it is 2 commands. Open PowerShell as administrator and run WSL-install. Reboot when it asks you to. When the machine comes back, Ubuntu launches by itself and asks you to create a username and a password. That password is your Linux password, used for sudo, and it has nothing to do with your Windows login, so choose something you will remember. Then, inside Ubuntu, run sudo apt update, and then sudo apt install build-essential gdb valgrind. Build-essential is a meta package. It pulls in GCC, make, and to C library headers in one go. Valgrind is a memory error detector we use much later in the book, and it is worth having now. One last piece. You almost certainly want to edit your code in a Windows editor while compiling it on the Linux side, and VS Code does that properly through its WSL extension. Install the extension, press F1, and choose WSL:*connect to WSL. The editor window stays on Windows, but everything behind it, the files, the compiler, the debugger, runs inside Linux. Keep your code on the Linux file system, in your Ubuntu home directory, rather than under C:. It is noticeably faster, and it avoids a whole category of line ending and permission oddities. That is WSL. Next, the verification lesson that everybody does, whichever platform you chose.